the Spark core. The Spark core is an underlying general execution engine for the Spark platform. All functions are built upon the Spark core, and it provides fast RAM-based in-memory computing. Provides referencing datasets so external storage systems can be used. Spark core is the foundation of the Spark system that supports cluster-based parallel operations, task distribution and dispatching, scheduling and coordination, input and output functions, RDD operations support. Control of shared variables are broadcast variables and accumulators, and this is also used and supported by the core. In operations of RDD, a Spark cluster consists of multiple nodes. Each node has an executor, a JVM, a Java virtual machine, running inside. Executors operate multiple cores, which can be used for various transformations and tasks. In Spark, parallel processing is based on multiple threads, as I have explained before, and being operated on multiple cores on the multiple executors on multiple nodes of the cluster simultaneously in parallel. So therefore, once again, the concept of cluster has multiple nodes. A node has multiple executors. And an executor will have multiple cores that it uses to process the data, and there are threads that the application actually runs and is processed on the cores. So we have multiple thread-based core computing on the executor of each node that exists within the cluster. And this is a concept that we will be using. A thread. What is a thread? Well, this is a sequence of programmed instructions that are independently managed by a scheduler. Threads are commonly used in operating systems. So on your smartphone and on your personal computer, on your laptop computer, on your iPad or tablet computer, all of the processes are operated based on multi-core threads. You have multiple threads executed on multiple cores, and some share and some are independent. A process commonly requires multiple threads to be executed simultaneously, sharing memory. Multiple threads may share a core to be processed or may be assigned to its own core. A core is a computing component with an independent processing unit that reads and executes program instructions. Multi-core processors have multiple cores on a single computing component. For example, we have a dual-core CPU has 2 cores. A quad-core CPU has 4 cores. A big-little processor has heterogeneous cores that share the same instruction set. Big cores have high computing capability and use relatively more energy than the little cores do, and the little cores have much more energy saving capabilities, but they are slower. So, more computation burden tasks are assigned to the big cores, where the light operations, including the daemon processes that run in the background, are executed on the little cores. And an example of a big-little CPU that's running on your computer or smartphone, if you bought it recently, then it probably has 4 big cores and 4 little cores operating all together. Spark variables and serialization. There are these 2 shared variables that Spark uses: broadcast variable and an accumulator. In broadcast variables, an application can send a read-only value set to all worker nodes, and that will be a broadcast variable. An accumulator is an aggregated value of multiple worker nodes. Only the driver can access the accumulator variable. Tasks can only write to accumulator variables, and the tasks cannot use or read the accumulator variables. Some broadcast variable examples: a data set is small enough to fit inside memory within a single executor. A data set can be loaded up on the driver as a lookup hash table. A broadcast variable is broadcasted to all executors. And these are some of the examples where a broadcast variable would be used. In addition, map transformations on the executors can just reference the broadcast variables to do dataset lookups, helps to avoid shuffle processes when joining datasets, and it saves a lot of time and processing. That's why it's used so effectively. Some accumulator examples. It's used to count events that are occurring during the execution, used frequently in debugging. Serialization is a process that converts the state of an object, which is a database, an app, a program, or something else, into a stream of bytes. Serialized byte stream can be reconverted back into the original identical copy of the program or the object or the database. Serialization is used for the purposes of data transfer over the network, saving RDD data to a solid-state drive or a hard disk drive, and persisting operations. In addition, it's used for broadcasting variables. Java serialization is the default serialization scheme. It is the most commonly applied one. Various object types can be supported, and you can support large serialized formats. It's relatively slow, so for production apps, faster serialization tools may be required. These are the references that I used, and I recommend them to you. Thank you.